Uh, Kevin is still not there, right?
Not yet, sir.
Okay, we'll wait for another 3 minutes. Did you guys watch the video that I sent you last day?
Yeah.
Yes.
Sorry?
Yes.
Yes.
Okay. Now you have a rough idea about wastewater treatment plant, right?
Yes.
Yeah.
Can someone ask from Kevin?
Okay.
Okay.
Yeah, we don't have it. I have it. So he is connecting.
Okay. You guys
Yeah.
go for the assignment brief for the wastewater treatment plant. Open that one, a Word document. Did you read it? Hello?
Yeah.
Right. Wait. Kevin, is he there? No, he's not there. Right. Here, we have to design a wastewater treatment plant for the same community. Right. Mention the one we did the drinking water treatment plant. So here, once again, we will have to assume the flow rate. Okay. But in this case, here now we will be designing a wastewater treatment plant today for a community. But what will happen with the time for the what will happen to the population with the time?
Increase.
Yeah, it will increase. So we have to consider that factor as well. when we are designing a wastewater treatment plant. Okay, so in your lecture, Dr. Shiromi has given you the basic guidelines. So here we will be using SLS 745, which is used for practicing wastewater disposal. Okay, and in the assignment brief, it is given the BOD values, COD levels of the wastewater that we have to purify. Okay, so when we design a wastewater treatment plant, hello, Kevin.
Yeah.
Yeah, okay, right. You are here, right? Okay. So I asked Jayanga and Supun to open the assignment brief for the design.
Okay.
Did you hear what I was saying about the population increment and so on?
No, sir.
Right. When we design, we have to consider the increment of population in the community. Here, once again, we are designing for the same community that we designed drinking water treatment plant, right? And we will be using SLS 745 standard for design. Now here, in the assignment, it is given the BOD level is 300 and COD level is 500 milligrams per liter. If you go to the standard given in the assignment brief, I think you guys have that standard, right? It was given in the lecture. Right. Anyway, I'll tell you what we have to do. We have to design a treatment plant where we can reduce these BOD and COD values, and we have to consider suspended solid as well. Within the effluent should be within the standard rate, right? That's what we have to do in a wastewater treatment plant. So the influent will be this given values, and we have to get an effluent of the standard value. Okay, I'm just giving you an idea what's happening in a wastewater treatment plant. Okay, right. So first, as we did for the drinking water treatment plant, you have to decide a design period. Okay, and based on that, we have to calculate the population which will be at the end of the designing period. So suppose you selected the design period as 10. Now then you have to calculate what will be the population at the end of the 10 years, right? For that, we have to design the treatment plan, right? So I will guide you through how to do the calculation. First, you have to assume a design period, and for that you have to use that table 2.1 which was given in the lecture 2 intake structures. Do you remember that? Yeah, there it was given for treatment plants what should be the design period. So we'll do the calculations as we go. So you guys start the calculations now. Okay, hello.
Hello.
Yeah, so here right. So yeah,
Another table in the wastewater lecture. It's a table 18.1 design period for wastewater. There's another table. The table 2.1 is for design period of waterworks. The specific one design period for wastewater works, another table in wastewater perspective.
you're talking about the lecture 7, right? Yeah, the same. Yeah, the for treatment plants, fixed facilities, it's the same value, right? So it should be design period should be between 20 to 25 years. Okay, so we'll assume that it's 25 years, right? Okay, and in the design period, it's given same as discussed in drinking water treatment. So for 25 years, now we have to calculate what will be the population increment, right? To do that, there is an equation. Okay, can you guys write it down?
Okay.
Okay.
Wait, I can share the. There are few methods to calculate the population. Okay. Uh, can you see geometrical increase method?
Yeah.
Yeah, there you have an equation. Pn equals, right, P times 1 plus Ig over 100 times to the power n. Can you see that equation?
Yeah.
Yeah. So write it down. Okay.
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 Right. Right. Now you can do the calculation. I hope you have written what are the meanings of the terms as well. Okay. Here, this should be a simple n. Okay. Number of decades. N, that power is number of decades. So now calculate the presentation. Population after 25 years for selected community.
So what is the geometric mean?
Yeah, for that one, you have to take IG as 23.5%, but here you should yeah, that's 100 distance, so 23.5. You have to write down those assumptions as well, right?
So for the number of tickets, we have to take it as 2.5 or
Yes,
Okay.
yeah, 2.5.
2 or 3.
2.5.
Oh,
Now here you can see how this is a sample example calculation we did to get the IG value. So you don't have to do that. You can take this value straight away 23.5 and substitute for the equation. Okay. Let me know when you're finished. Okay.
So we have to calculate the design population only.
No, no. We will continue. First, you have taken the population at present, and then you have
Yeah.
calculated the population after 25 years, right?
25.
For that
Yeah.
one, we have to design the treatment plan, right? Now, everyone finish up to that level?
Yes.
Okay, right. I'll share another table taken from SLS standard. Now, can you see table 1 per capita daily flows for different user categories? The table?
Yeah.
Right. From this one, now we have to find what is the per capita wastewater flow from one person. Liters per person per day. Right? Now here, user categories are given for houses, housing estates, apartment complexes, like that. You have to take one from luxury, non-luxury, low income. What should suit? You have to decide what will suit the foreign area. From that one, what should be the per capita flow? So we are considering all waste, right? Here they have given black water and grey water separately as well. Yeah, so you know what is black water and grey water, right? Hello. What is black water?
Yeah.
Sewage water.
Yeah. So black water is sewage water and grey water is washing and food waste, like that. So they are grey water. Now, in some cases, grey water is taken separately, and they are treated for the use after they will be used for irrigational purposes after the treatment. Right. Now, here we will take all waste as whatever the value from these three, what you decide, and based on that, calculate the flow rate for your treatment plant. Okay. Use the heading of the table. This is where you taken the